Hello everyone, welcome to this session on the second problem on cable. And the first session was on cable was nothing but a cable which have been placed at the same level and been subjected to a concentrated force placed at an equidistance of 10, 20 and 30 meter along the horizontal span. Now in this particular problem, instead of a point load, it has been subjected to a UDL. So diagram is not been given. By reading out the statement of the problem, we need to interpret the diagram and then start with the solution. To begin with, there is a cable of having a support at the same level and is been subjected to a UDL of 10 kN per meter over a horizontal span of 100 meter. So first thing is the supports have been placed at the same level, and the distance between the support, that is A and B, if you happen to name those particular support point, and the distance between the support is been 100 meter. So these are nothing but the distance between both the supports to be 100 meter, and it has been subjected to a UDL. It has been subjected to a load of 10 kN per meter. So as it has been subjected to a load of 10 kN per meter, so it will move in the downward direction, and this particular magnitude of UDL is 10 kN per meter. So that is what is the statement of the problem that has been mentioned. So up till here it has been covered. Then the cable has a central dip. Central dip means at the center. So as it is symmetrical cable, so distance between the either part till the center it will be 50 meter and 50 meter. So at a distance of 50 meter, the central dip has been given as 8 meter. The central dip has been given as 8 meter. We need to determine the magnitude of maximum minimum tension in the cable. So to find out the magnitude of minimum and maximum and minimum tension in the cable, first point is we need to determine the reaction component at the support location. To find out the reaction component at the support location, as it has been supported at A and B and the UDL is in the downward direction, reaction shall be in the upward direction at A and B, and this reaction shall be called as VA and VB at A and B. Likewise, if you happen to consider the section part A to C, if you happen to pull it downward, A will move towards the right hand side. So as a resultant, reaction component A will be towards the left hand side, marked as HB. Likewise, if you happen to put a load in the downward direction, HB will try to move towards the left side, and the reaction component at A will be towards the right hand side, which will be called as HB. So here the conventions that we have to follow will remain the same. Convention is all upward forces to be positive, all downward forces to be negative, all right hand side force positive, all left hand side force to be negative. Likewise, all clockwise direction rotation to be positive and all anti-clockwise direction rotation to be negative. So the same sign convention we shall adopt to find out the solution related to VA and VB. Now to start with the solution, take summation Fi is equal to 0. If you take summation Fi is equal to 0, VA is upward, so plus of VA plus of VB, both the forces are upward, so it will be positive, minus of magnitude of the load here is 10 kN per meter, so magnitude of the load is 10 kN per meter, minus of 10, so span of the load is 100, so 10 into 100, which will come is equal to 0. So total value VA plus VB will be equals to 10 into 100, which will be 1000. So this is equation number 1. So VA plus VB shall come out to 1000. After that, you can take summation Fx is equal to 0. So when you consider summation Fx is equal to 0, HA is a force towards the left hand side, so minus of HA, HB is a force towards the right hand side, plus of HB, that is equal to 0. So HA will be equals to HB, equation number 2. So these are nothing but the values of HA, HB, VA and VB. But till now, we don't have the solution or the realistic value of VA, VB, neither HA and HB. So we shall take a moment with respect to support is equal to 0, which will be moment with respect to either A is equal to 0 or moment with respect to B is equal to 0. Considering moment with respect to A is equal to 0, with reference to A, VB, with reference to A, VB shall rotate this particular cable in anti-clockwise direction. So minus of VB into distance between A and B is 100, so minus of VB into 100. Likewise, with reference to A, UDL is on the top now, this will rotate in clockwise direction, plus of 10 into 100 into 100 divided by 2, that is nothing but span divided by 2. So this value will be VB into 100 is equal to 10 into 100 into 50, that is 2 ones are 2 5s are 50 here. So 100 on the left hand side, 100 on the right hand side gets cancels up. So VB will be equals to 10 into 50 shall come out to 500 kilonewton. If VB is 500, substitute back in this equation to get the value of VA as 500 kilonewton. So these are the values of VA and VB which is being calculated now. Then if I know the value of VA and VB, I shall note down this particular value of VA and VB. VA value is 500, VB value is also 500. Now next task is to find out the value of HA and HB. To find out the value of HA and HB, I shall take the moment with respect to center point C is equal to 0. Then I have a choice. If I take moment with respect to C is equal to 0. Why C is equal to 0 is it is the lowest point of the cable. And on the lowest point of the cable, I shall take the moment because it doesn't have any moment that will come into picture. Anywhere along the length of the cable I can take because I don't know the anywhere distance in between. But I know the central dip distance. For that reason, I shall take moment with respect to C is equal to 0. Then, with reference to C, I have two parts of the section. One is the left hand side part of the section which is A to C. And on the right hand side section it is B to C. So there are two sections here. Left hand side is A to C, right hand side is B to C. So considering the left hand side part, left side which is A to C. So on the left hand side, the part of the cable will be represented like this. A part been marked here, C is here. VA value is 500 which has been calculated. HA is towards the left hand side. And magnitude of UDL shall also be represented here. Distance between A and C shall be 50 meter. Magnitude of UDL is 10 kilonewton per meter. Now I shall take moment with respect to C is equal to 0. So with reference to C, VA is upward which will rotate in clockwise direction. So VA into 50. Likewise with reference to C, HA is towards the left hand side which will rotate in anti-clockwise direction and perpendicular distance shall be 8 meter. What is 8 meter now? 8 meter is nothing but the central dip of that particular arch. That is 8 meter is the central dip of the arch. So this will be minus of HA into 8. Further proceeding, with reference to C, UDL is downward, so it will rotate in anti-clockwise direction. Minus of 10 into 50 divided by 2, that is equal to 0. So here VA value is known to us, which is nothing but 500 into 50 minus of HA into 8 minus of 500 into 25, that is equal to 0. So if you reframe this equation and then find out, HA into 8 will be equals to, if you take this on the right hand side, HA into 8 positive, it will be 50 into 50 minus of 500 into 25. So this particular value we need to find out now, which is 500 into 50, 500 into 50, 500 into 50 minus of 500 into 25. So which value will be 500 into 50 minus of 500 into 25, and that divided by 8, which value shall come out to 1562.5, which is HA value will be 1562.5 kilonewton. So these are nothing but the values. So again it is 500 into 50, 500 into 50 as it is, 500 into 25 as it is. HA taken on the right hand side which will be positive, so HA into 8. So HA value will be 1562.5 kilonewton. VA VB value will be 500 kilonewton each. So this particular value is being calculated as 1562.5, and this value is also 1562.5, which is nothing but HA is equal to HB. So both the reaction components will be same, which will be 1562.5. So these are nothing but the values related to the support condition. Next part is to find out the magnitude of maximum and minimum tension. To find out the magnitude of maximum and minimum tension, maximum tension here. So to find out maximum tension, I shall redraw this particular cable again. After redrawing the cable, I have a reaction component at VA and HA, VB and HB. Then we have a UDL which has been subtended throughout the length of the cable, which is of magnitude 10 kN per meter. Distance between A and B is 100 meters. And value of VA is 500, value of VB is 500. And this is 1562.5, 1562.5. So these are the reaction force component, 1562.5 and 500. Now maximum force or maximum tension will be at the position where maximum force is associated. Now here maximum force with reference to this point is at the support location, because anywhere along the length of the cable, this total length of the weight of the cable is been borne by which material, which part? It has either the support. So at the support location, the whole load will be subjected now. So for that reason, the maximum tension will be at this particular junction at the support location. Now to find out that, we need to find out the resultant at support. Resultant at support itself will be maximum tension. Result at support itself will be maximum tension. Now how to find out the resultant now? Here this is a force moving on the left hand side and force moving on the right hand side. That is a force moving on the left hand side, force moving on the right hand side. The combination of both these forces is nothing but the resultant force. Now if we happen to check out this particular force component, which will be having a resultant force component RA here, which will be VA, HA. Likewise, the same condition prevails here. This will have a resultant force, a horizontal force component HB, vertical force component VB. Combination of both will be a resultant force component RB. So these are the resultant force component, and this particular resultant force component will be passed throughout the length of this particular cable. So for that reason, we need to find out the value of RA. So RA, how to find out? RA will be equals to square root of VA square plus HA square. As the value of VA and VB are same, HA and HB will be same. So RA will be equals to RB, and that itself will be maximum tension. So that is what you have calculated here is a resultant. Resultant at the support. Support is A and B. So that itself will be maximum tension. We shall substitute the value of VA as 500 square plus 1562.5 square, which is RA value. So substitute this particular value, square root of 500 square plus 1562.5 square, and whose value will come out to 1640.55. 1640.55 kilonewton. So these are nothing but the values related to the maximum tension. So maximum tension is 1640.55 kilonewton. So if you happen to observe here, so these are nothing but the profile of the cable, and the same resultant force will be shown here in this particular fashion, which is nothing but placed in the second quadrant. Either you can have a force in the fourth quadrant, or else you can project the force in the second quadrant. Principle of transmissibility. And this force is nothing but T max. Likewise, you can either have a force in the third quadrant or project the force in the first quadrant. You can project the force in the first quadrant. This is T max. And this angle alpha we need to find out now. Alpha will be calculated as alpha is equal to tan inverse of VA by HA, and whose value we shall come out to 500 divided by 1562, that is 500 divided by 1562.5 tan inverse. So alpha will be equals to 500 divided by 1562.5 shift tan inverse, and whose value will come out to 1774 degrees. So alpha value will be, that is direction of the maximum resultant force will be 17.74 degrees, and the direction of maximum tension force will be 1774 degrees. So these are nothing but the forces that have been available at A and B, and those are nothing but the maximum tension force. Now proceeding to find out minimum tension force, that is minimum tension force. To find out minimum tension force, here we have two values now. Now what will happen here is, if you have a cut at the sag at this particular portion, the cable will have a sag like this, and it will also have a horizontal force. If you have a cut portion at this particular location, the forces that will be observed along this particular cut forces is, you have a horizontal force, vertical force, and then the vertical force. At this particular cut portion at point C, this is A, B, and at point C. At point C, you will not be observing any internal force which will be in the form of vertical direction. The force that you are going to observe here will be nothing but a horizontal force towards the right hand side and a horizontal force towards the left hand side. And here, since you have only one singular force, this force, that is force at C itself will be minimum tension force. Now what it should be now? As it is a force towards the right hand side, this force will be nothing but HA and this force will be nothing but HB. So T minimum will be either HA or HB. So what is the value of HA now? 1562.5 kilonewton. Because it is either a horizontal force that will be prevailing at this particular location. If you consider BC region, it will be HB. If you consider AC region, which will be HA. Now here, HA will be towards the right hand side because reaction component HA is towards the left hand side. Opposition will be towards the right hand side. Here HB is towards the right hand side. Opposition will be towards the left hand side. Net force at C will be, this one force will be positive 1562.5. Either next force will be minus 1562.5. Net force at C will be 0. So which indicates this is nothing but the position wherein it will be having a minimum tension force, and that minimum tension force is 1562.5 kilonewtons. So this is how we are supposed to find out the magnitude of maximum and minimum tension force. So this is how we are supposed to find out maximum and minimum tension force at the any position. Maximum tension force is resultant force at A or resultant force at B. Minimum tension force is force at C position. So this is how we are supposed to solve a problem related to a cable subjected to UDL. Thank you. Have a nice day.